This is homework set 48, our last set. Question 1 just asks us to determine if this sequence here is geometric. Now, geometric means that you get from one term to the next by multiplying by a particular number. Now, what if I multiplied by 4? Multiply by 4. Multiply by 4. All right, so I'm going to say, based on this information that we have here, is that the answer is yes, and r is equal to 4. Now, what about this sequence here in question 2? Do you think that's geometric? Well, look at the denominators. 5 times 5 is 25. 5 times 25 is 125. I'm going to say yes, but we have to be a little bit careful what we write here. It's not actually a 5. It's 1 over 5. All right, it's 1/5. But look at the signs. Positive, negative, positive, negative. So the common ratio there is negative 1/5. Now, if you're not sure, just how would you find that? Take that 1 over 25 and divide it by 1/5. What do you get? 1 over 25 times 5 over 1. So you get 5 over 25, which is 1/5. But you can see you've got that negative there. So r is negative 1/5. Question 3, is this sequence right here geometric? Well, just to be sure, let's try this. Let's do these divisions. What is 8 divided by 3? So take the next one, divide by the current one. All right, that's going to be like 2 2/3. But what about this one? And what about 13 over 8? Well, this is less than 2. All right, and then even 18 divided by 13, that's less than 2. All right, so I'm going to say no. There is no common number, no common multiplier here. So no, and if we say no, does not exist. Question 4 says that the following problem is geometric. All right, so it refers to a geometric sequence. We're given the first term, all right, so the first term is 1, the common ratio is 2, and what we want to do is find a sub n. Oh, all right, just a general term. Well, the general term is going to be, now here's our general formula for geometric. The general formula is this. A sub n is equal to a sub 1 times r to the n minus 1. So how about a sub n is going to be, a1 is 1 times r, which is 2 to the n minus 1. So how about just a sub n is equal to 2 to the n minus 1. But I'm thinking the textbook or the homework set might want it in this form right here. They might want that multiplier of 1. Now in question 5, we're given that this information here refers to a geometric sequence, and what we're looking for is the sum of the first 5 terms. Well, I have a formula for that. So do you. It goes like this. The sum of the first n terms is this fraction. It's a1, the first term, times r to the n, common ratio to the nth power, where these n's match, minus 1, all over r minus 1. Now, all these numbers that we need should appear in the problem. So we're looking for s sub 5. So s sub 5 is equal to, now, I'll write it up here. A1, the first term is negative 3. R is equal to 3 itself. All right, so we're going to have A1, the first term, negative 3, times R, 3 to the n. All right, now that's to the 5, minus 1, all over 3 minus 1. This is going to be negative 3. Now, just do this on your calculator. Just do it all at once. On your calculator, just type in this, 3 raised to the 5th, and then minus 1. Be careful how you do it. I got 242. So be careful on your calculator. You want 3 to the 5th, but then you want minus 1 out here. All right, so I got 242 all over 2. Now, here's what I see right away. 2 will go into 242 121 times. Negative 3 times 121, and I can actually do that one. How about negative 363? Right, that is the sum of the first 5 terms of that geometric series. Question 6 says, this is a geometric sequence, and what we want to do is find the sum of the first 8 terms. All right, so in this case, n is equal to 8. Now, what is a1? The first term, negative a third. What is r? We're going to have to get r. Now, I can do it like this. I just need one division. I know it's already geometric. They're telling us that. So just make a division. Take maybe like the second term divided by the first. So how about if we write negative 1/12 divided by negative 1/3? This would give us negative 1/12 times negative 3 over 1. That's a 1 and 4. So how about negative is positive 1/4? So I'm going to claim here that r is equal to 1/4. Now, just run a quick check. If you multiply 3 by 4, you get 12. 12 by 4, you get 48. I think we've got it okay. Now, the formula for the sum of a geometric sequence goes like this. S sub n is equal to this fraction, a1 quantity r to the n minus 1 all over r minus 1. So this will give us that S sub 8 is a1, which is negative 1/3, times r, which is 1/4 to the n. Now n is 8, right? It matches that one right there. And then minus 1, close that, all over r, 1/4 minus 1. Now you can see this is just a pretty cumbersome arithmetic operations. So why don't we use Wolfram Alpha? So go to Wolfram Alpha, www.wolframalpha.com, and type in this expression. Now, here's how I think you should type it in. Start with evaluate, give it a command, tell it what to do. Now look, you've got a fraction here. This thing's a fraction. So you want to offset the numerator and the denominator. All right, so you need parentheses to offset the numerator. So open up a parentheses. That starts the numerator. And then type in negative 1/3. Now parentheses. That parentheses there is this one right here. Then another parentheses for the 1/4. 1 divided by 4. Close that. Right? That parentheses is that one right there. Raise it to the 8th power. Minus 1. Now, close the parentheses. That is that one right there. Right, that one is that one. Now close this parentheses. That matches this one, and that closes off the whole top. Divide. Now, you have an operation down here. So parentheses, get all of it. So parentheses, 1 divided by 4 minus 1, and close it. Now, when you press enter, I got this as an answer. It's coming back two ways. It's coming back as negative a fraction, 21845 over 49152, but then it comes back as a decimal, negative 0.4444, and then it goes on and on. Okay, now are there any instructions here? No, there's no instructions to tell us how to round this off, so, I'm just going to write it like this. I mean, I could go out here, but really it doesn't make that much sense to carry a decimal that far out. Now in 7, we're going to find the sum of this infinite geometric series. So we have a first term. We have a first term here. A1 is 1/3, but no nth term, right? It doesn't end. It just keeps going and going. Can you see what r here is geometric? What are you going to multiply 3 by to get 9? 3. 9 by 3 to get 27. But you got ones in the top, so r is going to be 1/3. So it turns out the first term is 1/3 and the common ratio is 1/3. Now we have a formula for the sum of an infinite geometric series. It is the sum, the infinite sum. It's a nice formula. It's just a1 over 1 minus r. So what do we get here? So the sum of this infinite series is 1/3 over 1 minus a third. So how about 1/3 over 2/3? So this will be 1/3 times 3 over 2. Those 3's cancel, and I get that the infinite sum, if you just added up all infinitely many terms, you get 1/2. Now, XYZ homework might want it written like this, 0.5. So just whichever one works. To Nate, let's find the sum of this infinite geometric series. Now I know that the first term is 16, and do you see what r is? What is r? So how do we get from one term to the next? It looks like we're going to divide by 4, but we don't really divide. What we do is we multiply. So r is going to be not divide by 4, but multiply by 1/4. Now, S sub infinity exists when the absolute value of r is less than 1. That means this, -1 less than r less than 1. So look at our r. We have a fourth. Now a fourth is between -1 and 1. So we're okay here. So this will exist. Here's a formula for it. Formula is this. The infinite sum is equal to, pretty nice formula, it's just a1, the first term, divided by 1 minus r. So that is going to be for us a1, which is 16, over 1 minus r. How about 1 minus a fourth? So 16 over 3/4, that's going to be 16 over 1 times 4 over 3. So how about 64 over 3? That is what I think is the infinite sum. 9. Let's add up all these infinitely many terms. All right, so we're told it's geometric. So a1 is equal to 2/3. Now what is r? How do you get from one term to the next? Well, what if you multiplied by 2 on top, multiplied by 3 on the bottom, multiplied by 2, multiplied by 3. So I think r is also equal to 2/3. And -1 less than r less than 1, so the infinite sum exists. Here's our formula. The infinite sum is equal to a1 over 1 minus r. So in our case, a1 is 2/3 divided by 1 minus, now r happens to be 2/3 also. So S sub infinity is going to be 2/3 divided by 1/3. That's 2/3 times 3 over 1. Those will cancel. So you add up all infinitely many terms there, and you end up with 2. There's the first 9 problems in homework 48.